As we continue to develop our launch technologies, there's an increasing number of external partners who wish to not only understand, but also begin to G-harden their components for a unique launch environment.
So Neumann Space, it's a propulsion business, and I think a bit like SpinLaunch, we see the rapid change, but also the great importance of the emerging space economy. And as much as launch has to change dramatically, propulsion has to change dramatically.
Today we're at SpinLaunch in Long Beach, USA. Neumann Space is doing a partnership with SpinLaunch so that we can test our propulsion system for fit in the S20 satellite from SpinLaunch in their accelerator system.
When we first started the collaboration with SpinLaunch, obviously we're dealing with a situation that as engineers we don't deal with very often. We're talking 10,000 Gs here, and our system was not initially designed to take that. So we had to identify the areas of the design that were going to pose the most challenges in that environment and work out how to test them. To do that, we ran an ANSYS analysis on our existing design to identify those challenging areas. And then from that, we could work out where we had to implement some changes. We identified there was a particular board that carried a lot of mass that under 10,000 G would potentially cause some challenges. We took the initial version of that board, brought it here to SpinLaunch in California and put it in the tether that they have that simulates that 10,000 G environment.
After reviewing the results with them, we discussed a couple of minor changes to their system. 3 of the key takeaways from that first test had to do with complete underfilling of the capacitors, a change in design philosophy around the load path, and the third one also had to do with string compatibility in the high G environment.
We essentially, through an iterative process, increased the epoxy adhesive within the system to underfill the capacitors, increased the board thickness, and a few other small fixes, and through that process we were able to achieve the 10,000 G environment. When you first hear that number, it sounds insane. At the same time though, once you delve into that analysis and start actually crunching the numbers and thinking about how things are going to move under that loading, you realize that it is an achievable number. It didn't take too much to adapt that to achieve the 10,000 G loading environment.
Now that this is done, the next step is going to do the full 1U version of the Neumann Drive, call it the Neumann Drive -S for SpinLaunch, and qualify it for their accelerator and their satellites.
We see that the future of space is many launches, lots of vehicles up there, lots of need for propulsion. We don't see this as a sort of industry where we've got a launch every 3 months. It's got to be a launch every day. So we're very much excited about the idea that we can make this happen.